All right, this lesson is going to talk about geometric mean and how we're going to use that to solve missing sides in a certain kind of triangle. So let's take a look. First of all, we're going to just talk about what geometric mean is as far as a series of numbers. So let's take a look. These numbers, if you notice the pattern here, is not an arithmetic sequence because that would be adding each time. Here, what we're going to notice is that you are multiplying by 2 to get to the next number in the sequence, right? And then so when we want to get the average of two numbers, let's say we don't know what this number is, the average between two numbers that are being multiplied in a sequence, we do that by setting up a proportion. So 4 is to the missing number x as the missing number x is to the next number 16. So what you're going to find when you do this, the mean always shows up twice, and the other numbers, the low and the high end, show up in the other two places. So to solve this, I'm just going to cross multiply. X squared is going to equal 4 times 16, which is 64. And then to solve that, to get x by itself, I undo x squared by taking the square root of each side. So x squared, square root of x squared is going to just be x. And then I'm going to recognize that 64 is a perfect square. Square root of 64 is 8. So I can say that 8 is the geometric mean between 4 and 16. So let's practice real quick. The geometric mean between 9 and 16, well, if I'm looking for a mean, I'm going to put that number down twice, and then the other two numbers go in the other two spots. So that's going to be 9 and 16. Cross multiply. 9 times 16 is 144. And again, the square root of both sides. X equals square root of 144, which is just 12. Okay. The next one, I think I want to change this to be, because this is going to come out to be another perfect square. Let's change this to be 10, just so we can see an example. So the geometric mean between 4 and 10, I'm going to have a geometric mean going down twice, the other two numbers in the other two spots. X squared equals 40. And now this is not a perfect square, so x is the square root of 40. I need to simplify that radical. So I'm going to look at the multiples that made it up. If you don't think of any that are efficient, just go back to, or either just go back to, these are the two numbers I multiplied to get that, so just go back to those. 4 is a perfect square. 2 times 2 is 4. So 2 comes outside of the radical, and 10 stays inside of the radical. So when we're doing this work, we want to leave everything as a simplified radical. All right, so that's geometric mean, and we're going to use that to apply it to finding missing parts of a triangle. Now, this is only when we have a right triangle that has an altitude drawn with it. So this is an altitude. That little line is called an altitude, and it is drawn perpendicular to the base, and it goes through that angle. It's the tallest part of this triangle. So what I'm going to visualize is how this triangle, when I draw an altitude, becomes 3 different triangles. So I have my original big triangle, okay, and that's this big triangle. Then the medium triangle is this one here, right here. That's the medium triangle. And then my little triangle is that one right there. And then we're going to look in the next problem at how these sides work and how we can use geometric mean. So let's look at an example. So if I have this altitude of x and 4 and 9, and I want to figure out what x is, well, I'm going to show you how we do it with looking at the 3 similar triangles. So this side x right here is the bottom of the big triangle, the medium-sized triangle. So this is x. It is also the tall side of the small triangle right here. Then we need to put 4 into place. 4 is the small side of the small triangle, and 9 is the tall side of the medium triangle. So what I know from similar triangles is that 9 would be to x. I can set up a ratio. 9 to x equals x to 4. And I can solve this proportion and solve for the missing x. Well, if you'll notice, that's just what we did with geometric mean. And so we can also say that x is the geometric mean, write it twice, between these two numbers, 4 and 9. Now it came out in a different order because of the way it's set up, but it is going to be the same value when I cross multiply. So x squared equals 36. X equals the square root of 36. So x equals 6. Okay, so the shortcut, we're going to learn that the altitude is the geometric mean between this part right here and this piece right here. Okay, let's try another one. Now the variable is not the geometric mean, but I'm going to always write that twice. So 8 equals 8 is the geometric mean between this chunk and this chunk. Okay, cross multiply and solve that. That's as easy as it is. Now I'm going to go ahead and show you the similar triangles. 8 is the bottom side of the medium triangle. It is the tall side of the small triangle. It is the small side of the small triangle, x is, and 16 is the tall side of the medium triangle. So again, set up a ratio and a proportion, cross multiply and solve. So here we go. 16 times x equals 8 times 8 is 64. Divide both sides by 16. And x equals 4. And there you go. You've got the missing value for x. Let's do another example. All right, so here they only gave us the full length, the value x, and 25. Well, what I really need is this one. Well, that's just going to be 29 minus 25, so that's going to be 4. So I'm just going to use those numbers. So once again, labeling, x is here, and it's also here. 4, small side of the small triangle. 25 is the big side of the big triangle. I mean, big side of the middle triangle. Okay? Use similar triangles to set up a proportion, or I'm going to look here and I know the geometric mean goes twice. It is the geometric mean between 4 and 25. So x squared equals 100. X equals the square root of 100, which is 10. All right, that's when you have the altitude as your geometric mean. Now there's another geometric mean, and that is the legs. So let's take a look at that. All right, here, if the leg, this leg of this, we'll call it x, is also the geometric mean of the side that it's with, A, and the entire length, we'll call this B. That is our leg geometric mean. So let's label this. X is going to be the hypotenuse of the small side. It is also the bottom of the big triangle. A is the small side of the small triangle, and B is the hypotenuse of the big triangle. So now we're using the big triangle and the small triangle. Set up a proportion. B is to x as x is to A. And again, the geometric mean always shows up twice in your proportion. So I'm going to come over here and I'm going to say geometric mean is x. Write it twice. It is the geometric mean between the side it's with. And here's where we got to remember, it's not this amount like the other one, it's the whole length. So B is the total. Okay. And now we're going to say x squared equals a times b. X equals the square root of a times b, if you're going to solve that out. Okay, let's take a look at an example. All right, so the geometric mean x goes twice. It is the geometric mean between the side it's with, and the whole distance here. Okay, let's look at our similar triangles. This would be x, this would be 4, x is also the here, and 9 is here. 9 to x equals x to 4. Work it out. X squared equals 36. X equals square root 36, which is 6. All right, let's look at the other leg. It works the exact same way. It is also a leg, but now it is the geometric mean between the side it is with and the total length. So let's label. We've got y is the hypotenuse of the medium triangle. Let's see, these are the right angles. That's the right angle. 6, let's see, y is there, and it's also the tall side here. 6 is the tall side of the medium triangle, and we don't need 3 on its own because that would put us into a third triangle. We want to compare 2 triangles. We need the total length, so that's 9, which is the hypotenuse of the big triangle. So we can say y is to 6 as 9 is to y, setting up similar triangles. Or I'm going to know this is the geometric mean, write it twice, between 6, the side it's with, and the total length, 9. Y squared equals 6 times 9. 6 times 9 is 54. So let's see. Y is the square root of 54. Okay. Got to look, is that a perfect square? I'm going to put it in my calculator, and it's not. So I'm going to go over and simplify square root 54. Okay, well, how did I get here? I did 6 times 9. Okay, that becomes 9 is a perfect square, 3 times 3. 6 has no, well, it's got factors of 3 and 2, but neither one of those have matches, so the 3 comes out and the 6 stays on the inside. Okay, and let's do one more example. All right, so here again, this leg is not the geometric mean, but we still are going to list that twice. 8 equals 8, and it is the geometric mean between x and the total, which is 10. We'll match it up here, so this is the small side, and it is also the bottom of the big one. This is the bottom of the little one, x is, and 10 is the hypotenuse here. So 10 is to 8, is 8 is to x. So again, the geometric mean shows up twice. I'm going to cross multiply, and I've got 10x equals 64. Divide by 10, and x equals 6.4. All right, and that is the geometric mean. We've got 2 options. You've got the leg. When the leg is either this leg or this leg, and the altitude could be the mean. So you got 3 possible means. The numbers down here are never going to be the mean, so you're going to always look for those 3 possible geometric means and set up your ratio, cross multiply, and you have solved for a missing side. All right, that's it. See you later. Bye.